Before we go further, right? So this session is going to be more like what I learned so far, right? This is probably by this May, I'm getting into my third decade into the industry, like 22 done. It should probably in 20 plus years in the industry doing development all these days. Okay. And what I thought to share with you guys, since you guys are going to be tomorrow's programmers, I thought like let me share with you something which will be very interesting and helpful for you when you get on. And hopefully I see some of you guys in my office sometime or later as well. So with that, as the host said, like you got all the slides right here. So I think if you can go to the Bitly link, or you can share it, you can scan this QR code that's right there on my screen, so that like you can get to the to this slide decks which I'm using today, completely public. You can go there, and with a little bit introduction about what I did already. We got a fair bit of introduction. Any questions on this session or anything related to open source, Red Hat, on projects like Tektoncd, Knative? We'll be talking about that more, a little bit more during the session. You can obviously drop me a note. My email ID is there. It's kameshs@redhat.com. I'll try to respond as quickly as possible, but definitely I do. You can also follow me on Twitter. My Twitter handle is there, and the QR code right at the corner, where you can scan it to DM me on Twitter as well. And also one more thing, you can also reach out to me on LinkedIn, Twitter, at GitHub, wherever you feel right. I hope you guys are more on GitHub and other places as well today. And also, like, I'm happy to share with you the cookbook, what I call as Knative Serverless cookbook. This is a little bit more advanced techniques. You can download a lot of these free ebooks around microservices, Java, reactive programming, and lots more, right? Kubernetes, etc. So with that, so what let's do is like, since I want to play some game with you guys. So as I said earlier, so this game, what you see on my screen, is something which I want you to try that out. So this game is there probably once you click on the link, you should be seeing something like this here. Okay, so it's just on play game. I'm not a starter. I'm sorry. I'm sorry about this little glitch, guys. Like I totally forgot that I did it yesterday. So and then I'm trying to get this thing. I hope like you guys are able to see the thing, right? You can just go pop these balloons up there. So I'll leave it for some time for you guys to go play with it. Um, and then we'll play with it for some time, maybe like next 30 seconds or 40 seconds, something like that. Already wasted some time on that. You guys start playing with this. We'll talk more about what's behind this, like why this game is just to make fun, make things easier for us. I hope everyone is able to play, right? So right now they're able to see the pops, right? What you see on my screen, and you should click them to get your points also. Okay. And let me try to do something. Let me pop some few of my colleagues' faces also there. Let, let me see if this gives you something. Okay, you should see some bonus coming up. You should see some achievements popping up for you guys. I hope you're also able to see those pops. Some achievements if you click few balloons together, few all these things together, etc., etc. Right? I'll also do one thing. So I'll also watch the questions. Hopefully nothing of now. Great. I think thanks, Shivam. I think you guys play for a few more seconds. You keep playing, and then I will. After some time, you'll take a pause of the game, and then let me go ahead and do one thing. So since you have been playing for a few seconds now, let me go and pause the game. So that's what I'm going to do now. So let's go there. See, pause. If you see your balloons hanging right now, you'll not be able to play the game right now. The balloons are hanging, and then okay. Fun, right? I think I see a lot of fun. I think I want you guys to enjoy. Like it's. I don't want it to be a boring talk. Okay. So let's do one more thing. So let me start it back again. I just click play again. You should start the balloons popping up again, and then you guys will be able to play it again. Right? Let's play for 10 more seconds, and then I'll say like let's stop it. Right? So I'll do a countdown: 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Okay. That's it, right? The game is over, and then you should see the little balloon also there. This is my boss balloon, so which we did on this game earlier. So I think you should see something like that on your screen as well, right? What your point you got your rows, 3 in a row, 4 in a row, kind of stuff. Um, I hope like everyone was able to see their points. Unfortunately, when I'm doing these sessions live, right, I usually give away some goodies, but unfortunately, I cannot do this time because of this virtual. I hope I meet you guys sometime next year live, right? So that like we'll do this game again. Okay, uh, that's great, awesome. So one thing which I want to talk to you guys right now, let's go to the presentation, right, and then I'll talk about what's there in this game, right? So we played a game here, but we had some fun, but also bear in mind that we are also did something else. Okay, so I hope like you are seeing back my presentation right now, right? So we are on my presentation. Let me see if I can move ahead. But let's get to the context of this session, right? We saw about this presentation. We saw about this application. So you saw that I was able to do something behind the scenes to make this application run. So, but if you think on a whole, right, holistically, there are a few things which was involved behind the scenes. So that's exactly what you're going to see, like the Pandora's box that I started about, like what you're going to open up right now. Now you're going to see few things like your platform, your programming language, and your processes. Right? All these things makes your application development. So when you saw this application, even it's a simple game that you saw today, but what happens is that I have to create a platform for this particular application to be deployed so that you guys can access it. And also I have to put on some restrictions so that I can control how the games go. That's what you see pause, play, and I think even earlier, if you saw, I did not provide a token, even I was not able to access the application to start the game. Okay. And you'll also need some programming languages because there are multiple stuff involved in this. For example, yeah, there's a Node.js there, there's a Java component there, which is both involved in this, where we need to tie them together to make them work together, what we call as APIs in today's world. But these are something which is there, right? We have a programming language, you have a process, you have a platform. All these things form together in the process of an application development. So that is something we'll see more about what all things important. So when I call this Pandora's box, it's a little bit thing behind the scenes, right? Because if you are not able to understand or apply the right platform, the right programming language, the right processing for an application use case, then it's going to be like a Pandora's box, which is going to be a disaster, right? And so that's what something which we want to be very cautious. And I'm going to give you a few hints where we say, okay, when you want to do this, when you don't want to do this, all right? So, and all it's all my learnings. It's not hard and fast tools. It may change from your career point of view as well. Something which you want to do in your career, like it might be a little bit different, but it gives you some kind of what I call a rule of thumb. Okay, shall I use this? Shall I don't use this? Okay, shall I use the other one? Shall I use this? Right? Based upon these are a few things which you're going to talk about. Okay, right? Great. So let's go further. So before I go further, right, I come from Red Hat. You know that Red Hat is a truly open source company. Open source. But one thing which you might be having in your mind is what is open source. Okay. So we've been talking about open source people are contributing. I heard a few of you guys are also doing open source contribution, but what exactly is open source? Okay. I put down 10 points on your screen. Let's go one by one and see what basically is open source. Okay. So by open source, anything to be open source if it satisfies all these 10 points. Okay. The first one is free distribution. What I mean to say, like, we don't get money for distributing the software. Okay. That's what is open source is all about. Second one is a source code. We also distribute the source code as well as the binary. It's available for you. So if you're able to get those things together, then that's also open source. And derived works, obviously, why we do open source is make for people to modify the stuff and use it as they want. If that's the case, then it's the derived work should also carry the same license terms which the original work has. All right. And also be open source doesn't mean that we don't respect the integrity of the author. So if you want to respect the integrity of the author, which means that we restrict the direct modification of code, which is most of the case that happens with open source, where you send pull requests if you're aware of GitHub, and then the patches get merged into the actual source code if that looks good. Okay. And then again, we don't discriminate who can contribute, who can use the same thing. We also do that. That's what no discrimination against persons or groups. Same thing with you can use it for whatever purpose you want. That's also there. And distribution of license, right? How we should have one license which could also apply for redistribution of the software as well. Okay. And one thing we should also be very peculiar. Last 3 points is about like we don't want the license to be more specific to a product. When you what I mean by this, when you use my open source product along with another product, commercial product of yours, you cannot restrict the open source project license on the some of that. Okay. So and again, it cannot be restricted along with the software as well. Finally, it should be technology neutral. So if you're anything, if you're using anything that satisfies all these 10 rules, right, then we call it as open source. Okay. I put on a link right there at the bottom, open source definition. You can go there where you can see about what exactly open source is all about. Okay. But why I should use open source? That's again another one which we need to think about, right? There are 3 important points which I put on here. Okay, this is why you should use open source. So where you get a collaboration around, right? Working with community of developers with same wavelength, right? What you want to do, right? And since you are sharing with them, asking people to redistribute and then do changes and then make changes to what I think we are making a bigger impact, right? We started as a small project and then we make it bigger and bigger and bigger, right? Which means that people start using that, all right? And also, since it's open source, everything is open. It gives you high quality of software, right? And it's also secure because I know what the software is doing because I can go into the source code and see what's it's doing, right? It gives you more confidence when you actually write a software, all right? But you'll be wondering, like, why I'm starting with open source, okay? So one of the things to avoid the problems, what is the Pandora's box, which I talked about earlier, which is going to be our theme throughout this talk, is that when the code is source, I'm sorry, when the source is closed, then what happens is that so you'll not be able to understand what's running behind the scenes. Okay, you might have faced a lot of softwares like that. I don't want to quote names of those closed software. They're not, but the thing is that you are not your customer is not a king at that point, right? When we go into an industry, we build an application. We also always build an application for somebody to use that, right? Which means that they should be the king and we should not be the king. Okay, that's the whole idea. So we should always be the servant. When I do this, like when you do open source, I know what's going wrong. I can go and fix it up. Okay, so that is the very first step that you take when you're going to build a quality software is that you always embrace an open source. So for that, you need to understand what it is and why you should do that. Okay. And at Red Hat, we do a lot of that stuff because we rely on open source software and then we sell open source software end of the day, which makes us still one of the greatest companies in the world right now. Okay. And then let's go further. So we have got our open source software, but what's more required, right? We'll go for the next step, right? On one of the P's which we're going to talk about today is programming languages. Okay. So you'll be understanding why programming languages is important. Okay. So let's take a simple example, right? Right now, you'll be writing applications, this one. So you'll be seeing applications, you'll be writing in various of programming languages. It could be Java, it could be Node.js, it could be Python, it could be Golang, and it could also be Rust, okay? But let me understand, most of you guys would have worked in many one of these languages, right? So it's not that you would have exposed all, but this is something which you'd be right now when you enter into the IT industry, start writing your own application, we'll be starting to see all these things. But why I'm talking about programming languages here, right? None of the programming languages is bad. Okay, this is something which you have to stop doing it when you get into the industry, right? I've seen people, I've seen tweets, I've seen social media posts. We say, okay, this language is wrong, this language is garbage, it does not do this. This language is something else, it does not do this, right? There's nothing like that in the software world. So all languages was made for a purpose, right? And then you have to see the purpose and use the language. That's more important. Okay. So it's like just like in any other language which we speak, right? The moment we learn another language, we are obviously learning the other culture as well. Okay, that's what we say. In the same way, if we start to learn a new language, which means that we are learning those language syntax and semantics and the core purpose why it was built in. Okay. The very first language I learned, I should say 1994, 1995, is that I learned Pascal and Photon. Okay. And I know that the languages, no enterprise applications are built for Pascal, but you know that all the scientific computations are still, even today, are run with Pascal. Okay. So which means that language is not bad, right? Because the purpose of the language was to do scientific computation, right? And similarly, like if you have Java, Python, Go, or Rust, it really depends upon what's your purpose of the language also. Okay. Beyond purpose, there's also one more thing which we need to understand is what is the architectural style that you're going to follow that also decides what programming language you need to use. Okay, I put on a very three common architectural styles that is available today, which you any one of these, even when you build any application, mostly it will fall under these categories. I'm talking more about enterprise commercial applications. it will fall under any of one of these categories as well, right? It could be services, which means that it is autonomous, loosely coupled, but you have your own control. It's a client-server architecture, which is talking about right here. When you talk about microservices, I'm not sure how many of you got introduction to microservices as part of your syllabus. Probably microservices something is a little bit more different from services, where we do smaller things, single purpose, stateless, and independently scalable. So this is what you see, right? For example, if you imagine about microservices, you could things what happens in Netflix or Amazon app. You see the things changes from time to time, right? So each one of the things that get deployed on these apps, your movie tiles, or let it be your product information or something else, right? Even your shopping cart, everything got as a microservices, small units, and then they get deployed, right? Which means that they'll deploy them independently without affecting others. That's how you see a lot of differences in your application. If you see an Amazon app or a Netflix app, a lot of changes happening by the time you'll be watching some movies, right? Which means your movies or your shopping doesn't get disturbed because of that. Okay. For that information, these guys do hundreds and hundreds of production deployments in a day. That's what the control that microservices gives you. And finally, the another architectural style is about serverless. What I mean is that's not nothing called a serverless there. What I mean here is that we become resource conscious. Okay. When you run any of these software, obviously you'll be running in a data center or in a cloud. Okay, that's what we do today. Okay, we'll see about that, more details about that a bit later. But what basically I want you to understand here is that so you also need to be conscious about the resource I use. For example, I develop an application. That application runs from 9 to 5. All right. But what happens after 5, right? I don't any nobody uses my application. My application doesn't get any requests. Nothing needs to be done. But unfortunately, I deployed on a cloud where the application is running 24/7. Okay, but actual use is only from 9 to 5 every day. But you're running the application for 24/7, which means that I'm wasting the rest of 5. The entire resources that is consumed by my application is waste. Okay, I could either take it and use it for some other application which needs it, or I can also even shut down the thing, right, to save my cost. So these are the architectural. So these all the programming language this also drives the architectural styles that you want to build the application on. Okay. So that's the reason why no programming language is bad. We need to choose them wisely. Right? Right. So, but I'm just giving you, I'm just giving you a rule of thumb here. It's my own perception when to choose what. So, because one of the saddest thing with the IT information technology industry is that whenever something new is introduced, right, people always follow that. Okay, without understanding whether that particular architectural style or way of programming is going to help me or it's not going to help me, right? So that's something which I also want you to take aware of, right? Just apply these rules. This is a small set of rules which I'm putting across to you, right? Whether I want to go with services or microservices or serverless, I just put some bullets around like what's the way when you have to choose this particular style of architecture. And if it's a very good enterprise application, right, which means that sometimes you'll be combining all these three styles together to build a robust enterprise application. Again, I'm talking about what I'm talking right now is that again, your programming language or whatever you're using right now is going to play a big role in it. All right. So that's what the importance of any programming language is. So whenever you go into the industry, whenever you go into the start working for any of the company, just keep open mind. Even if you do your own startup, just keep open mind and see all the possible languages available in market. Because right today, the application which you develop is all polyglot, which means that we develop with multiple applications together, like the balloon game which we played earlier. It had Java in it, it had Node.js in it, it had Golang in it, behind the scenes. Okay, I'll talk more about that later. But that's what the application is comprised of, including an API, which I'm controlling as well. Okay, so which means that I have all the combinations of multiple programming languages playing together to get you one simple game like that. Imagine if you are developing a complex application, then you might need the powers of each individual languages. All right. So I'll take a quick pause here to see if you have any questions. Otherwise, we'll get moved further. If you have any questions, you can pop the questions on the questions tab. I can take some questions. Otherwise, I can continue and take the questions at the last. I have 10 minutes reserved for the questions.
Okay. So I see a couple of questions there. One is Linux operating systems are open source now and stand as significant competition to corporate operating systems like Windows and Mac OS. Yet no open source social media platforms or search come close to even their corporate counterparts.
Okay, so I think it's not like that. I think probably you will not seen the search. It's more because of the domination. For example, right, this application which I opened on Chrome, right? Unfortunately, I don't know why this application doesn't work on any of the other features, right? But what's happening right now today is like because of the closed source, we got lots of security issues right now. Even you would have seen the same issue with WhatsApp few months earlier, right, where they have some issues with the privacy policy. Right? We cannot, nobody can control that. Okay, it's similar to that. So even I think there is lots of open source search engines that's available. If you heard about DuckDuckGo or something else, like you could have seen that instead of Google, there are also companies that's behind Google. You can just go. I think all the browsers, if you go to the preferences of the browsers, you see this software. Many of them, other than Google, are open source one, which respect your privacy as well. Okay, so that's what exactly mean to say when you use open source, your privacy and your data is with you, right? Because nothing is closed, right? When you start to use closed software, something's there, and they make money for that. Company like Google, they're using the data to make money, right? That end up that they give it to their advertisers. So obviously they have to use that thing. But imagine it's open source, it's nothing like that. You cannot do that at all because you know what code you're using, which means that you are on the safer side.
So then there's a question, how important is it to have a deep understanding of the compiler or interpreter of the language that we use? Should we prioritize the theory of the programming language or the applications?
Okay, so I would. That's a very nice question actually. So it actually depends upon what is your use case application. From whatever I explained right now, it's more at skimming of the surface, right? You understand. So for example, I'm a Java developer for 20 years right now. But only thing is like I learned the syntax and semantics about Java and others thing, which is common to all programming languages. All it takes for me to learn a new language is just to know the new syntax and semantics. Okay, nothing bigger than that. Maybe like there might be lot of what you call deeper things inside that, like your compiler and other stuff, which mostly in my case, since I'm more on the commercial side of things, I'm not going to. Okay, but if I'm going a deep programming level where you might need to debug, obviously those knowledge will definitely help you because to debug the application, see if there is some performance issues with that. Okay, that is very much important, but it's not a necessity.
Then there's a question, if a new company or startup wants to establish uh, following the open source ideology like Red Hat, what are the
Mhm.
challenges it has to overcome?
Okay, ideally there might not be bigger challenges when you start with open source. To be very precise, the one of the biggest thing that you have to do is start building a community. So community is the backbone of any open source software. Okay, if company like Red Hat, if you see that we started this business quite earlier, like 20 years, 25 years right now back, right, and we are still known as Linux company, right? We started only as Linux company, and we are still known as Linux company, but we do a lot of other things like the platforms, like chip platform like Kubernetes. We do a lot of stuff on middleware like Java and other stuff as well. So, but for people to understand those things, right, you have to have a bigger community contribution. Okay, make yourself popular, even if you're doing a startup with the open source in mind. Make yourself participate in the community so that you're known in the community that you guys are contributing back to the open source is the way by which you can establish yourself. So that is a very important thing. Community and contributions are two very important pillars for you to be very successful with open source. And then that gives a trust for people who are going to start using your product. Okay, these guys are doing contribution to this particular product, so they know it. So let's get the services from them. So that's how things start to grow.
Uh, there's one question by Tejas. He says, just like a company releases its IPO to overcome its finances, can same
Mhm.
analogy be followed regarding company's code base? Like company open sources its code base to the developers,
Mhm.
so that developers can contribute in their code base for overall growth.
I think I did not get a question. Can you come again
Yeah,
on
he
that?
says that the analogy of a company releasing its IPO to overcome
Mhm.
finances can
Mhm.
be applied to open source. He gives an example, like company open sources its code base so that developers can contribute or invest in their code base for overall growth.
Okay, so I don't call it as an IPO thing. I think I don't take that analogy here because this is a little bit why we want to why we start with open source code. And open sourcing a code meaning to say I'm trying to build a community, right? I'm trying to build the trust. Okay, I'm trying to say to people what I'm doing and also giving what you call licenses to be. In open source, we don't call them as license usually, but I'll still call it as license. We use the license to give them to make what they want, right? To make a bigger impact, as we start earlier, right? A usual analogy is like your food recipe that we do, right? So I make a cake, for example, and then I give the recipe of the cake to my friends who come with me, right? And their friends take this recipe again and they say, okay, let me add something more onto this and make another different cake, another different recipe, right? And then they make a different one and they give it to their friends, right? And it goes like that, right? It goes like a chain, which means that I'm creating a bigger impact, right? By sharing my code, allowing them to modify. This is little bit different from what the IPO stuff which is there. Probably you can use a recipe analogy that will be close to what open source is.
Shivam asks your take on crowdsource decentralized applications.
That's a very tricky question. Shivam, I think I don't have an answer for that right now. Maybe I'll try to get you an answer offline if that makes sense. Okay. I think probably if we have time more in the evening, I mean, after the session is done, maybe we can discuss a little bit more detail on that. And then maybe I can try to get the answer right away. Okay. So let's get back to the session and then see what we have. Okay. So right now, I understood programming languages is important, right? And right now, what I'm going to take you to the next step is that, so I have programming languages. Everything is ready, okay? But I need a platform where I need to deploy this application. This is the second P of the three Ps which you're talking about right now, okay? So even though we do the best of the best programming, the best of the best applications we develop, everything done. If your platform is not good, then we are going to have problems, okay? Site, for example, then suddenly there is a festive time people throw on it to buy things, right? If that's the case, then what happens if my platform is not scalable, then I'm going to lose business. Okay, so I need to make the platform scalable. And again, maintainability, we tie back the maintainability again to the programming language and the architectural style which you use. That also is going to contribute a lot towards your maintainability of an application. All right. And also running instances, right? Because since in some cases I might be running on cloud, we'll see about what are the various platforms you're on. So when I'm running an application on a cloud, then it means that one compute which I take on a cloud is not just going to help me running one little application. I might be having multiple applications running on the same instance just to use the compute whatever I bought for, right? All right. So that is very important as well as. And also like ensuring quorum. And what I mean by quorum here is that in some cases, when you run an application, right, it runs in a master slave architecture. What I mean by that is there'll be a leader and the other slaves will have the data synchronized across it, right? Which is that like any given point of time, I should need to have 3 instances or 4 instances of application always running so that I have the quorum leader election thing running on that. Okay. If something goes in between, then what basically happens, I'm going to lose data. So my platform should also take care that something like that doesn't happen anytime point of time, so that my application also ensures score. And last but not the least, the thing which you talked about earlier, rolling updates without service disruption, which means that I push something into production and then I should see something changing up on my thing right away. I think I told you the example of Amazon or Netflix. A lot of these guys does these things, right? A lot of people, what they call as microservices architecture, they do this very easily, right? So because they know like whenever these are following microservice architecture, which means that each application is not dependent on each other, which means that I can push in changes without disrupting the others one, right? So these are not the only the requirements, but there'll be more requirements depending on the use case. By the way, these are very fundamental requirements that is required for you to choose a platform, right? And with that, so what we basically choose is like your platform could be any one of, for example, AWS or Azure or IBM Cloud or Google Cloud, right? It could be in many of one of these what we call as cloud. But sometimes I'll also put something within my data center. What I need to say here is that so some applications or some data which will be very confidential. I don't want it to put it on public cloud. So I want to have it on my local data center, right? Which will be there, and then I use some other thing on the public cloud, right? Eventually, it could be in cloud or in data center, right? If any of these choice, whatever the architectural styles which we talked about right now, in today's world, your every of these things should be something called as cloud native architecture, which means that my application which I'm developing today should be deployed on a cloud native platform, which could be, I'm just saying an example of AWS, Azure, Google Cloud or something. There might be something else, but also it should also be deployed on my local data center as well. So cloud native architecture styles, it allows you to do smaller microservices, and then I can deploy anywhere I wish. I can move the application around, right? I can move it on AWS, I can move it on Azure, I can have it on IBM Cloud, I can go with it. Okay. But the old principle which drives all these things is the five things which you see, the fundamental points which you saw about making platform choices. Right? Great. But if I imagine for a second, right? I mean, I'm going to use platforms like any of these cloud platforms, any of my data center, right? But when I use that something like that, there's going to be one choice that you need to do, right? That's where I'm getting into my process style of things. Is that there are multiple things I'm going to talk about process. I cannot cover the complete stuff, but I'll try to cover a few very important points. So when I want to move my applications across, as you saw, right, cloud native architecture, right? So which is the trend of the industry today, where everybody says, I want to live on cloud, I want to move things on cloud, right? So when you want to deploy applications on cloud, the very first thing is very important is packaging. So what I mean by packaging, okay, it's packaging of your application, right? So let me take a very simple example, right? As I told you, I'm a Java guy. This example could be applicable to any programming language for that matter. But if you imagine that I'm a Java guy who is doing this stuff right now, here I'm saying, okay, I want a var or EAR, which is the basic binary thing you take, and we package the application and we deploy the application into your production. Okay, so this is the usual step what we do when you're doing as a developer, and then you say, okay, and then I email my operations guy, okay, hey, I have my package ready. Can you deploy it into production? Okay, I just send an email to him, or there'll be some ticketing system where you do this. But if you pause for a second and imagine, when I write my email, just imagine what you have done, right? My application development platform, where I develop as a developer, where I develop my application was on Windows 7 desktop with JDK with Java 8, and Wildfly 9 is again open source application server. And then I use the MySQL database for my database. All right. So this is my development platform. But imagine for a second where I'm going to deploy is going to be Red Hat Enterprise Linux 7, JDK 8, WebSphere 9, and Oracle Database 12. Okay. It's totally different. All right. So now you imagine the discrepancy that's going to start. By the time I send an email on a Friday evening and go back, Saturday, Sunday off for me, and then come back on Monday, application is not deployed. Why is this? Because you have two different heterogeneous environment where the application is getting deployed, and you don't have a common packaging mechanism which will allow these files to go off. That's exactly what you're talking about packaging, right? This is the same problem will come for you when you use multiple cloud providers, because they each one has a different way of deploying the application. So I need to have some common mechanism, right? That's where you got into these kind of Docker kind of things, right? What we call as Linux containers. Okay, so Docker file is a very famous format for which where I compute everything together, right? I have my container, I have my Java application server, custom configuration, dependencies, and my application source code, right? As a jar or var EAR, right? In Java world. Okay, I package everything together and then deploy this application into cloud, which means that when I container as a Linux container, my application can run in any of these clouds. For example, we took the examples of AWS, Azure, IBM Cloud, and Google Cloud, and even a private data center. So what basically happens once I containerize it, so my application is going to run anywhere, wherever I want, because my container has all the things that it needs to run. It has an operating system, as we saw earlier. In the previous, it does a container guest OS, it has an application server, it has custom configuration, dependency, everything, which means that you'll not go back to the old challenge, which we're talking about, like I have this development environment, I'm deploying it in a different environment for my production. So what you also make sure is that I'm kind of testing my application implicitly hundreds of times when I develop my application, because I containerize it and test it. So which means my application is also quality tested implicitly. Okay. So this is very important. So we need to talk about containers. So that gives you that's the first process of packaging, which makes sure that you package your application as Linux containers, so my application can run anywhere I want. Okay. But when I say anywhere I want, right, there also comes when I have hundreds of containers together. What basically now happens to me is that I want somebody to control my application. If you remember, we saw about the platform requirement like stability, maintainability, ensuring quorum, all these stuff, right? So these are not taken care by your underlying platform, right? IaaS platform, what you call infrastructure as a service, like AWS or Google Cloud or Azure or anything, right? They don't take care of all these things for you, right? When it comes to your application, it's your responsibility that you have to take care of that. That's exactly where we need something like what I call as application orchestrator. Okay. The application orchestrator basically takes care of your containers, what we built right now, and make them they run the way we want, and then get them deployed across these cloud, even including a private data center. All right. So Kubernetes is one such application orchestrator, which is kind of become a de facto standard to deploy application in a cloud native world today. So that is something which you can use to deploy an application. All right. But I think what you imagine right now, you think about, okay, I did the deployment, but the problem is like Kubernetes is an open source again, right? It has been there in open source for quite a long time, but how can I make it enterprise ready? Okay. So what I mean by this is that you can have open source project, right, where people do contribute. But the thing what basically happens is that when you get into production, like especially with the financial institutions or anything, they look for quality tested and then compliances, etc., right? That's exactly what we did with OpenShift, right? And that OpenShift is nothing but it's enterprise Kubernetes. Okay, what we did is like we are the top leading contributor to Kubernetes. We keep contributing to upstream Kubernetes, and then we also take that and then get it into build a trusted platform on top of Kubernetes and give it to our customers, right? That's what we call it enterprise Kubernetes. In open source world, we have two things: upstream and a downstream. Upstream is something like which is contributed by the community, comes together, do contribution, all these stuff. And then there's a downstream where we also take a particular version or a label or a tag, and then we make them, harden them, quality test it, and release it as a supported version, right? That's what people want. When I call us enterprise, I mean support that's required for them. Okay, that's what we do with OpenShift. Eventually, whatever runs on Kubernetes is going to run OpenShift as well. Azure, Google Cloud, or IBM Cloud. But in today's world, the requirement is such a way that I want to leverage the services from multiple cloud providers. That's what I call hybrid cloud. Okay. When you go for this such thing, a developer onboarding onto this kind of a cloud native architecture. So what basically happens is that he has to learn all the cloud intricacies, right? So that we solved using OpenShift. What we need to say, like, you don't need to worry about as an application developer. Don't worry about which cloud you're running. Just make sure that you're able to make applications for Kubernetes. And then with OpenShift on these clouds, we'll make sure that your application is running perfectly. So that I can use, for example, S3 storage from AWS and Watson from IBM Cloud and functions from Azure and something else from Google Cloud, right? I can use all these functions differently together and make them work together in tandem, right? Which means that I have a hybrid cloud native journey for the organization. This could also be potential tomorrow. We see a lot of acquisitions happening, right? Which means that they'll bring in their own set of applications, which might be running in different cloud, where I need to have some kind of a platform which allows me to run in multiple different clouds as well together, right? I can be able to talk to these services as well. Okay. So that's what we talk about hybrid cloud. So we got about processes, we package the application, and then we use Kubernetes so that we can orchestrate and run the application as Linux containers. And because of OpenShift and Kubernetes, we're able to run the application on a hybrid cloud journey as well, where the user or app developer it understand only one stuff. Okay, perfect. The last process, what I want to talk to you guys is about DevOps. Let's go a little bit more, right? So what I want to talk to you guys is about developer onboarding. Okay, so let me go a little bit one slide back. I'm sorry. Here. So when a developer is onboards, okay, we talked about polyglot thing right earlier. So when a developer onboards on this, it could be a .NET developer, a Node.js developer, or a Java developer. Okay, you could be any developer who's onboarding onto your platform. But just for a second, right? These are the 4 points for you to kind of digest. Okay, so when I first started my own programming as a developer 20 years back, so I have literally waited for 1.5 months to get a machine, a computer, a desktop computer, to start working on my daily day job. Okay, so which means that it follows all these process, right? I have to file a ticket, and the manager has to approve it. Once it's approved, I need to go for tickets and tickets because it will not have administrative privileges. It will not have few things, which means that I have to follow this process. And after 1.5 months, literally, like I get a machine to start working. Okay. Until then, I just go to the office, sit down, write something on a paper, work on something on paper, or share a machine with somebody else. Okay. But with today's speed, that is something which is totally unacceptable. Okay. So when a developer onboards the day one, even if you do a startup also, make sure that when a developer onboards the very first day, as formalities are done, you should just click a button or a link, and then you should have his development environment up and running. Okay. That's exactly what I call as self-service API driven quota managed infrastructure on demand, which means that, so this is a little bit more complicated work, but eventually I click on a link, I log in with my user ID and password which is given to me, I get a platform for this. Okay, so let me show this also. When I click on this, I go to something called as the developer sandbox. I think this is free. I strongly encourage you guys to go try this out when you get your link. I'm putting this link on the chat box. Let me grab this link. So let me go to the chat and I'm going to put this on the chat. I'm looking at a different screen here. There you go. So we talked about a lot of things, right? OpenShift, Kubernetes, Java, the process behind the scenes, etc., etc. If you want to get a feel of what all these are about, right, so that you can know tomorrow, you can just go try this out. All you have to do is register yourself. So the same developer site, what I was talking to you about earlier, where you can also get your free ebooks as well. Okay. So you go to developers.com. This is exclusively for developers. Log in onto this platform so that you can get the feel of the OpenShift platform which I'm talking about, which is an enterprise Kubernetes. And also relate to what I right now, what I'm giving you right away on a screen, right? So I don't have any preparations, I don't have anything right there. I shared a link with you, which means that when I click off this particular link, you're going to get your development environment ready, which means that I'm going to get into my work, the day job, the day one I'm on a mission. I'm not going to wait for years together or months together, weeks together. Okay, so that's exactly what this is: self-service, API-driven, quota-managed infrastructure on demand. Which also means that as a company, as somebody who has to control this environment, I also know what type of developers on board and make these kind of environments ready for them so that they can start developing on the environment on day one. Okay, just go try this out when you have time, and then let me know how you feel, because we are adding more features to it going forward. But that gives you an environment like what you see or going to see on my screen right now. So the moment you provision yourself, register yourself, you're going to get a development environment like this. So which means to say that I'm going to get this environment, I can deploy the application like this. Whatever application you have on hand, you can just go to the deployment. Okay. The same balloon this is the balloon application thing which you're seeing on my screen on OpenShift platform, which means that I have a Node.js application. I have two Quarkus. Quarkus is nothing but a Java application framework. So which probably you can also, I think that's also a good link to post to you guys. Just go check this one. Quarkus.io. Just post that link also on the chat so that you can go try that one. It helps you to develop easy Java applications in fraction of a second. Okay. So these everything put together running on a platform which is orchestrated by, these are all containers. What you see on my thing, the Linux containers that is running on my screen. And if you see this one, I said like I have to have complete number of instances running, which means that, for example, if I'm going to say delete the pod, right? The pod is what the application runs. I'm going to make it 0. Okay. So which means that like it scales down automatically. So the pod goes down. And then I can also bring that app in fraction of a second, just go again and then say pod go on 1. And then that application is going to come up in a fraction of seconds as well. Okay. And also I can just go click this one and then go see the details. I have an administrator view, developer view, all these stuff. There is more of a stuff which is going to be involved here. And then I can go delete this pod as well. I think, let me see if I can delete the pod. Okay. I can just go here, the pods, click on this. So which means that I'm going to delete this pod, as you see on my screen. But the good thing is that when I delete the pod, I said about healing. So it automatically creates a new pod for you. Let's delete this, and you see the container getting created here, right? The Relax container gets automatically created because it's not what it needs to deploy. So this is something what I call an application orchestration is, right? In a simple way, right? I'm orchestrating the complete application. So if something goes down, I'll be able to get it up and running in seconds. All right. So, but how do I do all these things? That's again a process thing which you want to think about. It's all about pipelines. When I onboard developers, so this is a very good book that I suggest you guys to go read about, because this is something which is very much applicable in today's world. Okay, how do I do continuous integration? Which means that I have a self-service environment. I have something ready for me. I have an application code ready. I've tested it. So what should I do next, right? I just go commit this source code onto any one of the version control, which could be like, probably would have heard about GitHub, GitLab, Bitbucket, or anything. Once the application is there, then what basically your environments like Kubernetes or anything is going to use something called as pipelines and apply principle called as GitOps. Okay, I just put the links on the sources section of this where you can go read more about that. So basically what happens, GitOps is nothing but whatever is residing in Git, GitHub or GitLab anywhere, right? It's a source of truth, which means that whenever I take my application and deploy my application is going to take anything from Git and then deploy, package it, and deploy my application. All these things are going to happen automatically. Okay, that's what is called as pipelines. Okay, so, but why is pipelines is required? And the principle of GitOps is because with GitOps, what basically happens since everything is version control. Even if my environment totally goes down, I can bring up another environment in a different cloud, apply the same set of manifests, then which we going to bring my application back up and running. Okay, and OpenShift and Kubernetes support them naturally with a framework called as Argo CD. I also put these link back in the resources. We just go read. It's a very interesting topic for me, at least. I hope you guys also like this. So what basically this allows you to do is like I can convert my deployments every 4 months. Like for example, if you read about those models, right, the project process models like waterfall or agile or anything, right? So basically, in a waterfall model, companies like Amazon or Netflix, or Flipkart, or anybody else who are applying microservice architecture are able to do this. Okay. So this again is a principle. So these are the three important processes that I want to highlight to you guys because that's something which you'll face immediately the moment you get onto your work on day one. Or even if you do a startup, just try to enforce these principles from the day one so that it's easy for you in the long run. Okay. I think that's pretty much I have, but what I want you to leave with a little story, right, before I end, okay? So this is a little story about a fox, right? Probably like a fox was there, and then this fox basically saw a dead elephant, okay? It want to eat the dead elephant, but unfortunately, what happens is that the fox cannot eat it by itself because the elephant's skin was so hard. It needs somebody like a tiger or a lion to kind of tear his flesh off, okay? So it was just waiting beside the particular dead elephant, and it saw a lion coming up there. Again, it asked lion, "Can I'm saving this thing for you? Can you tear the skin for me, right, and then eat it?" Unfortunately, the lion did not like this because it always wanted to eat fresh animals. So he said, "I cannot do this." So it went off. And then the tiger came the same way. And then what basically happened is like it asked the tiger to see, okay, their hunter hunted this, and unfortunately, use a poison arrow. So you cannot probably eat this one. So I'm safeguarding from other animals. So the tiger went away because he seemed that to be a poison. And there came a vulture again, lastly. And then it also said, okay, he said the vulture that I'm safeguarding it for the other hunter who needs the skin. So obviously he'll come when he comes to see you poking the skin, then he says like he'll go to kill you up. Okay. So the vultures also went up. Lastly, he got a leopard coming that way, and he told the leopard that this is a very tasty elephant. Probably you can just tear it off and eat it. But I'm the king, the lion, asked me to safeguard for him, so he's went out to bring his family. So I'll be alerting you when the king comes, right? So that's what he said. And the leopard started tear this off. Okay. And the moment it tore off, the jackal shouted like the lion is coming. Okay. And now what happened? The leopard ran away, saying, fearing that lion might kill him. And now what basically happened is that the jackal was right now is able to eat that elephant by himself, right? Because the leopard has done the job for him. A simple thing is what it means here. The moral here is that when you start to work, it doesn't mean that you need to be clever. Obviously, that's undeniable. A smart worker is always more important, right? He can come up with easy problem-solving skills that help him to rise fast through his ranks. Okay. I want to leave with this model because this is something which you have to keep in your mind because this is very important. That's the reason why I highlighted few things out there because when you have a closed mind, when you don't know how to link things together to build an application, things are going to become hard for you. Okay. So just keep this in mind. I think, and anyways, if you have any questions, as I said earlier, obviously you can reach out to me after this. With that, I'm going to say goodbye to you guys, leaving with a bunch of resources. Obviously, these resources are available when you have the slide deck with you. I think I posted the slide deck as well. And I think I'm taken a much longer time than what needs to be. So I'll get back to the host. If they have any questions to take up.
Thanks for the great session, sir. And if anybody you have any questions, please put them in the questions tab, and I'll pass it to sir.
All right, let's wait for a few minutes. I think so. While we wait for the questions, probably as I said earlier, I am also leaving some bunch of book links on this chat as part of the appendix, so which you can go. I strongly recommend you guys read all these books. These covers all the concepts which I talked about right now. These are very good books to get there. And also, like, I'm also leaving you with the bunch of cookbook downloads or the books which is free from Red Hat. If you go to those download links, you need to register yourself. You can download all these books around Knative and then around Kubernetes. You can also read about the Quarkus, which is talked just now about. And then we also have a bunch of books about microservices and databases, um, Microservices architecture using Servicemesh, and how to do microservices for Java developers. So there are much more books we keep adding to that. So all is required is that you register there and then download these books for you. So there are a lot of resources for you, obviously. And then also you can participate in those deep dives, which you used to take, where you have hands-on sessions, which we run every fortnight, monthly on these things. You can go to those sites, register yourself as well. Okay. The Sandbox link again I posted here. So if you want to try how OpenShift Kubernetes looks like, deploying an application, you can follow the Sandbox as well. Okay. I think we don't have much questions. I think I've taken a longer time in the evening, probably.
Completely
So
fine.
if you don't have any questions, sorry.
I said that's completely fine. I mean, it was a great session. So.
All right. That's great. So if you still have any questions, obviously you can post it back to me via my email. I think let me go to my first slide, right? That's where I have my email IDs for you guys. I'm just going to go there. So let me go to my first slide, okay? Obviously my second slide. So if you have any questions, drop me an email here, or you can just reach out to me on DM me on Twitter or LinkedIn or GitHub, anywhere you want. I'll be happy. If you're an open source contributor, you can contribute back to our tutorials. I'll be happy to accept your PR. I can review and accept your PRs as well. All right.
This.
Sure. Thank you so much, guys. Have a wonderful day. Take care and stay safe. I hope I'll meet you guys sometime in future on a live session. Okay, in person.
Thank you so much for joining in, sir.